Hey guys, this is the answers to the second page. So this starts off with the screenshot you see right here. For this problem, the main thing is you had to figure out what equation you could make. And you have equal angles right here, but you don't know this angle, and you can't say that this is x or y. You'd have to give it a new name. So knowing that this is 3x and this is y doesn't really help you make an equation. But the equal angles correspond to equal sides. So this side and this side are going to have to be equal, and that's the equation that you're going to make. X squared minus 96 is equal to 4x. Now from here, since you see you have a quadratic, you want to move everything over. So I subtracted 4x on both sides. And now you have a quadratic equation. So from here, you're going to either factor or you're going to use the quadratic formula. I'll use the quadratic formula. Negative b would actually be a positive 4. Plus or minus the square root of b squared, which is 16, minus 4 times a, which is 1, times c, which is 96, negative 96, all over 2 times a, which is 2. So the first thing we're going to do is we're going to simplify this a little bit. So I'm going to consider this to be a negative 4 times negative 96, and negative 4 times negative 96 is 384, but it's positive. So then I'm going to add it to the 16 because it's positive, and I get 400. Well, the square root of 400 is 20. So that comes out evenly. 4 plus or minus 20 over 2. Well, 4 minus 20 over 2 is going to get us a negative answer. And x can't be negative because then your side would be negative. So I'm going to use 4 plus 20. You get 24 over 2. And that equals 12. Once you get 12, at that point, you could plug it in to any of the equations. I mean, it doesn't matter which equation you plug it into. The big deal here is, though, the only thing that's going to help you find y is if you plug it in here. So 3 times 12 is going to get you 36. And you know 36 plus y plus that other angle, but the other angle is going to be the same thing as y. So I could actually say y is equal to 180 degrees. And then from there, you're going to find out that y is 72. Next problem is you have to prove that RAY equals BAN. So the first thing I'm going to do is I'm going to highlight those. And I'm going to use a different color. And I would really suggest that you use a highlighter when doing these problems. It helps you really see what triangles. So I have to get those triangles congruent. And all of a sudden I see the information they give me is that these two angles are equal. Well, if those two angles are equal, I'm going to right away make these two sides equal, because that's the isosceles triangle theorem. And that also gets us two sides of the triangle. Same thing goes here. Two angles in the same triangle are equal. That means the sides of that triangle are equal. Well, right there, you have equal sides. You already have two sides of the triangles equal, and then they have vertical angles right here. So that's how you wanted to do that problem. You have to state the given. So you would state that this angle, this angle, this angle, and this angle are equal. Now from angle, we'll do this one first. So angle ARY is congruent to angle ABR, and that's this right here. So from this particular, that's the given, from that reason comes that side RA is congruent to side BA. And that would be the converse of the isosceles triangle theorem. Okay? And because you're given the angles, so you have to prove the sides. Now, this right here would be the other angle. Angle AYN, this angle right here, is congruent to angle ANY. And that also is the given. Now from this one, you'd be able to say that these sides are congruent. So that's YA is congruent to NA. You could have also said AN and AY. And again, that is the converse of the isosceles triangle theorem. Now, from those two, the vertical angles have nothing to do with any of this. So that would just be RAY is congruent. I'm talking about these angles right here. BAN, angle, and that's vertical angles. And that's not really attached to anything because you could have said that from the very beginning, vertical angles theorem. Now, from these three things come that the triangles are congruent. You write that all out because of side, angle, side. But you would need the three lines because you're talking about side, angle, side. Last one is you were given this triangle. So right away, you could have said SAS because they have a side, an angle, and they share this side. If you wanted to, you could have used the corollary where you have a isosceles triangle with an angle bisector, so you know that this perpendicularly bisects the base. So you could have said HL because you have a hypotenuse and a leg. You could have said angle side, so there were a lot of different things you could say here. For the last one, the biggest mistake we saw from people is that they started talking about these sides as congruent. But the big thing here is when you have a parallelogram, the first thing you can prove is that this angle is congruent to this angle because of alternate interior angles. That angle and that angle, and they share this side. So the easiest one to say would have been ASA. Now you could have proven a couple other things, but that would have been the easiest one.